So for one, we're going to be talking about identifying and graphing sequences, okay? We're going to be talking about two different, explicit and recursive, and the recursive is a little bit more difficult, and we'll go over that slowly in detail, and I'm probably not going to have much on your assignment over it. You'll be doing it more later. Okay, so your vocab says a list of numbers in a specific order, which is a sequence. And you've done sequences. You've done arithmetic and geometric sequences. So for example, 7, 9, 11, 13. And you could continue that pattern. You would know which numbers come next looking at the pattern of that sequence. So what would come after the 13? 15. Okay, so that's what a sequence is. Each of those elements in a sequence is called a term. So every one of those numbers up above is a term. So like 9 is the second term is 9. They're all terms though. 7 is a term, 9, 11, 13. But the numbers in the sequence, or the elements, are your terms. Now the rules you're used to are explicit rules. We've only done explicit rules. It defines the nth term as a function of n for any whole number n greater than 0. Used to find a specific term in the sequence without finding any previous terms. So basically it says plugging in the numbers. You're given a value for that variable and putting it into the equation. It's an explicit rule. It tells you exactly what to do. And this is what you're used to doing. This one's the easy one. So for example, and we're going to put in function notation, you're usually used to y equals something x, right? But we're going to use f of x, which is a fancy way of saying y. It's called function notation, equals n squared plus 2. Okay? So that would be an explicit rule. I could put any value in for n, and I could solve for the function of n. So let's just say f of n, whoops, shoot. Let's make n 1. Our input is 1. So now I have 1 squared plus 2, which gives me what?
2 squared, or 3 squared?
No, what's 1 squared?
Oh, 1.
And
Two.
what's,
Yeah,
yep, and then plus the 2 gives me
3.
3. So when f of n, if n is 1, your f of n is 3. Do you guys remember function notation?
No, I don't think we did this last year.
So like f of n is like a y equals like 3n. It's the same thing as y equals 3x. It's just a different way of writing it.
3?
No, not necessarily. So y is, you're replacing y with f of n, the function of n, okay? You're replacing your x with just the n, whatever number we put in there. It's just function notation. It's solved the same way as like y equals 3x, except for we're using the function notation. Is that confusing?
Yeah.
Let's try another one. Let's do f of 2. Okay, so instead of n, we're going to put in what for n? So 2 squared plus 2 equals 4 plus 2 or 6. Okay,
So
that is just explicit rule. What you've done before using f of n for y and n for x. And we'll go over some more examples down below.
Like, the only part I don't get is, like, what, you know, everything is that?
Okay, so the harder one, which I'm not gonna even go over the example till later because you guys are gonna be like, whoa, this is super hard. But it's not if you just slow down and go through it. Okay, is the recursive rule. Okay, the recursive rule states it defines the nth term by relating it to one or more previous terms. So the example I'm going to give you, and we're going to do it down below, is like when f of 1 equals 2, f of n equals the function of n minus 1 plus 3. And we're going to do this problem down below because I don't want you to get confused yet, because the rest of it's easy. And we're only going to do one example, and I don't remember if I've even put one on the assignment. But this is on your ACTs. And I'm hoping you do more of it in Algebra 2. We can dive deeper into it too, but I just want, it's part of this lesson, explicit and recursive rules. Okay, so let's go over the explicit, which you already know. Breaking it down, Pretty easy way you did it like in middle school, okay? It says to complete the table and state the domain and range for the sequence. So if n is 1 and the function of n is 15, what do you think when n is 2, what is your function of n going to be?
30.
30, right? So this would have had to have been 3, right? When n is 4, what's the function of n?
Oh, 60.
60. So what rule are we using? What is our explicit rule?
Sequence?
So the function of n is going to be what?
15.
We're taking 15 times n, right? Or the way you saw it before was y equals 15x. Make sense?
Yep.
It's how you write them, okay? So we're really breaking this down to how you did it in middle school. Okay, so now this would have to be 5, right? When n is 6, what is f of n? 90. Okay? So if I list all my domain of this function, right? What are the domains of this function?
1, 2, 3, 4, 5, and 6.
Awesome. Okay, and then the range is all your output, right? All your y values or your f. This is like x, right? And this is like y. So I would have 15, right? What else? 30, 45, 60,
75,
and 90. Awesome. Okay, so now we've just related function notation to domain and range. X and y values. N is like x, f of n is like y. So now we can write these equations down below and find the next, it asks us to find the first 4 terms. Okay? So I'm going to show you how we do it in a chart, and you can use that chart on your assignment. And I want you at least to show your work on at least one. So n, right? Our rule, we're going to take n squared plus 2, right? N squared plus 2, and that's going to give us our y value or our f of n, right? So it's just like an input-output table that you've done before. And it said the first 4, so what are we going to pick? 1, 2, 3, and 4. Okay, so I got that from here. I just put my f of n equals what? I'm trying to find, this is like my y, right? My input's going to be my n value, my output's going to be my y value, or my f of n. So now I just fill them in. 1 squared plus 2 equals 1 plus 2 or 3. Now I'm going to put 2 in for n. 2 squared plus 2 equals
plus 2.
4 plus 2, which equals 6. Okay. And then I have 3 squared plus 2, which equals
9 plus 2.
which equals 11. And then 4 squared is my last one, right? I'm just putting it in for n. Plus 2 equals,
16 plus 15.
which is
18.
18. So my first 4 terms are 3, 6, 11, and 18 from that function. Okay? Make sense?
Should we do that for every one?
Let's do, yep, so let's do this one for number 3. Let's make a table again. So I'm putting in values. I'm doing 1, 2, 3, and 4 on all of them, right? And then my function is 3n squared plus 1, and then my output is going to be f of n. What am I going to get when I do that rule to all these numbers? Okay?
So it's going to be
So 3 times
3 times 1 squared
n squared, which is 1 squared, right? I'm going to use parentheses. 1 squared plus 1.
equals
So 3 times 1 plus 1 is 4,
Yep.
right? Got it?
Do we have to write the second part like the equals?
No, if you can,
Okay.
no, I'm just doing it to show you. But I want you at least to write this first part, okay? So 3 times n squared plus 1 again, right? Oops, I should put it, what is my n?
2.
2 squared, right? So if I were to write that, that's going to be 3 times 4 plus 1, which equals what?
Oh, 3 times 4 is 1 is 13.
So f of n is going to be 13. When n is 2, f of n is 13. Okay, so now I'm going to put in 3. 3 times 3 squared, right, plus 1. The only thing that's changing is our n value, right? So 3 times what? 9 plus 1, which is?
28.
Good. And then the last one is 3 times what? 4 squared plus 1.
Equals 16.
16 times 3 then is 48, right? Plus 1, which is 49. So these are your first 4 terms. Okay?
That's
Now-
your answer?
That's your answer. But I want to see your work too. Okay? How you're getting them. Because this is your first time doing these. Now the fun part. We're going to do this one as a recursive. Do you see how in these ones we have an f of n equals? Well, on this one, an f of n equals f of n. Well, we need to know what... We need to know one of those. We need to know a previous rule like it says up here. Okay? Because it says... Use the specific term in the sequence without finding any previous terms. So I'm going to give you... Sorry, this one we're doing the recursive. We're going to relate it to one or more previous terms. That's what we're going to do now. So on this problem, we're going to use recursive, and I'm going to tell you the f of n, we're going to use your example up above, or f of 1, right? What did I tell you f of 1 was? F of 1 equaled,
N plus, N, or equals 1 squared plus 2.
no, right here. What was f of 1? 2, right? I'm going to show you how to do this now. F of 1 equals 2. This is going to be a little bit tricky. The first time you see it, it might not make sense. So we have our n value again, right? And we want to do 1 through 4. Our f of n, okay? So f of n is going to equal f of n minus 1 plus 3. This is our function rule, right? And that's going to give us our output. So what we're doing is figuring out this part of it. Okay? So we were already given f of 1, right? We already know what it is when it's 1. What is f of 1 going to be?
2.
So when I put it in, I'm going to get 2. So I don't have to solve it because I know the answer. When I put it into this function, it's going to give me 2. I'm going to use that definition to find the next ones. So for the function of 2, f of 2 is going to equal f of 1, which we already found, which is 2, right? F of 1 plus 3. What was f of 1? 2. So this is really 2 plus 3, which is 5. Okay? Once you get the hang of it, it's going to get really easy, but it's kind of confusing at first. Okay, so now let's do the third one, which will be the function f of 3, right? So we're going to use the previous term, which is what? What comes before 3?
2.
F of 2, right? Plus 3. We're using this rule. Equals, what was f of 2? We just found it.
5.
5. So now we have 5 plus 3, which is 8. See how fun this is?
No.
So now we're going to do it with 4. So f of 4 equals, what's our previous term?
8.
F of 3, right? Plus 3, which is 8. You're doing it right. 8 plus 3, or 11. You did one. Yay. I think we have time to do number 5, and then it'll be time to go. Okay? So this one here is an example of a recursive rule. Everything else we've done is explicit because that's what you've done in the past. Recursive, you have to know one of them. You have to be given a previous one, right? Do you see how I told you what one was? Then we could fill that into our equation to find the next ones. Okay? That was our only example of recursive. Let's go ahead and do number 5. And then we'll call it a day. We'll have to do the back tomorrow or when I get back. Okay, so I'm going to fill out my table again. So n is going to be 2n minus 1 squared, and that's going to give me my output of f of n. And I'm going to do 1, 2, and 3 again, right? And 4. 4 terms. So I just fill those in. 2 times 1 minus 1 squared, right? I just fill it right into that function rule. What's 2 times 1?
What, oh, 2 times 1 is 2.
Right? So 2 minus 1 equals 1 squared, right? Which gives me 1. Then we have 2 times 2 minus 1 squared. What's 2 times 2? What's 4 minus, I just wrote down the answer instead of 4 minus 1 squared, which is 3 squared or 9. Now we have 2 times 3 minus 1 squared. What's 2 times 3?
6.
And what's 6 minus 1?
5.
So what's 5 squared?
10. Or no, 25.
25. Okay, the last one. 2 times 4 minus 1 squared. What's 2 times 4?
8.
8 minus 1?
7.
And 7 squared is
49.
49.